Hello and good morning. We'll be looking at the application of the circle diagram. Now, from the previous lesson, we should be having an idea of what the induction motor is and its full construction. To come up with a circle diagram, should the details of the construction of the induction motor should be at your fingertips. So, what are the expectations in this session? I expect you to analyze the three-phase induction motor performance using the circle diagram. I expect you to approximate equivalent circuit of the induction motor. I expect you to get knowledge on how to calculate induction motor operation losses. I expect you to be able to calculate the mechanical power output of the induction motor, and I expect you to calculate the electrical torque. Finally, I expect you to be able to calculate the rotor current of an induction motor. One of the things that the circle diagram analyzes is the phasor diagram. The phasor diagram is a graphical representation of the performance of the electrical machine. A phasor diagram gives relation between current and voltage only at a single circuit condition. Motor parameters, power factor, torque, slip, and copper losses efficiency are graphically presented. And on this side, we can see what the circle diagram of an induction motor is. Basically, you'll find something like this. Here are the two pictorial representations of a circle diagram, and inside, you'll be able to find the phasor diagrams. Here we look at the equivalent circuit of an induction motor. The no-load current and the no-load angle are calculated from the no-load tests of an induction motor and are plotted as shown on this side by this diagram. The angle between the y-axis and the line OA is the no-load angle, and its cosine is the power factor of the angle. Correspondingly, the line OA, when plotted, stands for the no-load current from the experiment. Secondly, the short circuit current and the angle obtained from the blocked rotor tests are also plotted. These are shown by the lines OC and the angle theta B. The line OC is the short circuit current, and it should be larger than the no-load current. The angle between the y-axis and the B, this angle between the y-axis and B is now the short circuit angle. And it's always smaller than the no-load angle. We have two more points to note on the equivalent circuits. The right bisector of the line AC is drawn to bisect the line, and it's extended to cut the line AE, which gives us the center of the circle. That stator current is plotted in the circle diagram according to the scale. Here, friends, I urge you to be careful while choosing the scale. There are more parameters to note on equivalent circuits. The output power is given by the line MB, line AC's power line. The total copper losses are given by the line GM. The line AD is the torque, which gives the torque development by induction motor. The line DE then gives the stator copper losses, and the line CD gives the rotor copper losses. Let us now look at the calculation of the induction motor parameters. First of all, we look at the maximum power, the maximum torque, and the maximum input power. All these three are indicated on the circle diagram. Here is the maximum power, the maximum torque, and the maximum input power. How do you get the maximum output power? Well, we get the maximum output power when the tangent to the circle is parallel to the line. The point M, the maximum power point M, as seen in the previous slide, is obtained by drawing a perpendicular line from the center to the output line and extending it to cut at M. How do we get the maximum torque? We get the maximum torque when the tangent to the circle is parallel to the torque line. And this is obtained by drawing a line from the center, and that line should be perpendicular to the torque line. That torque line should be extended to cut the circle. And that point, as seen in the previous slide, is marked point N. That is where we obtain the maximum torque. How about the maximum input power? This occurs when the tangent to the circle is perpendicular to the horizontal line. The point is the highest and it is drawn through the center. It is drawn through the center and extended up to point S. On the previous slide, it is marked the point R. Assignments are meant to make you learn more, and here I leave you with an assignment to be done in groups. Go and briefly discuss the advantages of using circle diagram in analyzing the induction motor. Also, state and outline the 4 disadvantages of using the circle diagram in analyzing the induction motor. Class, unless there is a question, we've come to the end of the lesson today.